Docker architecture. Docker's architecture is designed to provide a lightweight and efficient way to package, distribute, and run applications as containers. The architecture consists of several key components that work together to enable containerization and manage containers. Here's an overview of Docker's architecture. Docker Client. The Docker Client is the primary interface through which users interact with Docker. It accepts commands from the user and communicates with the Docker daemon to execute those commands. Users interact with Docker by using the Docker command line tool or other Docker-compatible client tools. Docker daemon, Dockered. The Docker daemon is a background service running on the host system. It is responsible for managing Docker containers, images, networks, and volumes. The Docker daemon listens for API requests and performs container-related operations. It manages the lifecycle of containers, handling tasks like creating, starting, stopping, and deleting containers. Docker images. Docker images are the building blocks of containers. An image is a lightweight, standalone, and executable software package that includes the application code, runtime, libraries, dependencies, and settings required to run the application. Images are created using Docker files, which define the instructions for building the image. Docker containers. Containers are instances of Docker images that can be run and managed on a host system. Each container is isolated from the host and other containers, providing process-level isolation. Containers can be started, stopped, and managed independently. Docker registries. Docker registries are repositories for Docker images. Docker Hub is a popular public registry that hosts a vast collection of pre-built images. Organizations can also set up private registries to store and distribute their own images, enhancing security and control. Docker Compose. Docker Compose is a tool used for defining and running multi-container applications. It allows users to describe complex application setups using a simple YAML file. Docker Compose makes it easier to manage interconnected services and their configurations. Docker Network. Docker provides networking capabilities to allow containers to communicate with each other and with the outside world. Docker networks enable various modes of communication, including bridge networks, default isolation, host networks, no isolation, and overlay networks, across multiple hosts. Docker volumes. Docker volumes are a way to manage and persist data generated by and used by Docker containers. Volumes can be attached to containers, allowing data to be stored outside the container's file system, making it more resilient and easier to manage. Docker Swarm. Optional. Docker Swarm is Docker's native clustering and orchestration solution. It allows users to create and manage clusters of Docker nodes, enabling features like load balancing, service discovery, and automatic scaling. Overall, Docker's architecture allows developers to build, ship, and run applications in a consistent and isolated manner, providing benefits such as portability, scalability, and efficient resource utilization. It has become a cornerstone technology in modern software development and deployment workflows. Docker Client-Server Model. The Docker Client-Server Model is a fundamental architecture that underpins the Docker platform. It consists of two main components, the Docker Client and the Docker daemon. These components work together to enable users to interact with Docker and manage containers and images. Here's an explanation of the Docker Client-Server Model. Docker Client. 1. The Docker Client is a command line tool, often referred to as the Docker command, that provides a user-friendly interface for interacting with the Docker daemon. 2. Users issue commands to the Docker client to perform various actions, such as building Docker images, creating and managing containers, and interacting with Docker networks and volumes. 3. The Docker client sends API requests to the Docker daemon to execute these commands. Docker daemon, Dockered. 1. The Docker daemon is a background service that runs on the host machine. 1. It manages Docker containers, images, networks, volumes, and other Docker objects. 2. The Docker daemon listens for API requests from the Docker client. 2. When the Docker client issues a command, it sends an API request to the Docker daemon, specifying the desired action. 3. The Docker daemon then performs the requested actions, such as creating or starting a container, pulling an image, or managing network communication. 4. The Docker daemon communicates with the host operating system's kernel to create and manage containers, leveraging features like namespaces and C groups for process isolation and resource allocation. Communication flow. 1. The Docker client and Docker daemon communicate over a Unix socket or a network interface. 1. By default, the communication takes place over a Unix socket, /var/run/docker.sock, but it can also be configured to use a network interface, TCP socket, for remote communication. 2. When a user issues a command using the Docker client, the client sends an API request to the Docker daemon. 3. The Docker daemon processes the request and interacts with the host's kernel to perform the necessary actions. 4. Once the action is completed, the Docker daemon sends the response back to the Docker client, which displays the output to the user. Docker daemon and its responsibilities. The Docker daemon, Docker, is a core component of the Docker platform that plays a crucial role in managing containers and their underlying operations. It runs as a background service on the host system and is responsible for a range of tasks related to containerization. Here are the main responsibilities of the Docker daemon. Container management. 1. Creation. The Docker daemon is responsible for creating new containers based on Docker images. 1. It allocates resources, sets up namespaces and C groups for process isolation, and manages the container's file system. 2. Starting and stopping. The daemon starts and stops containers as requested by the user through the Docker client. 2. It manages the container's life cycle, including process execution, resource allocation, and network configuration. 3. Deletion. When a user stops or removes a container, the Docker daemon cleans up the resources associated with the container, freeing up memory, CPU, and file system resources. Image management. 1. Pulling and pushing images. The Docker daemon is responsible for pulling Docker images from registries like Docker Hub or private repositories. 1. It can also push images to remote registries. 2. Image layering. Docker images are built in layers, and the daemon manages these layers to create efficient and reusable images. 2. When multiple images share the same layers, the daemon optimizes storage usage by reusing these layers. Networking. 1. Network configuration. The Docker daemon sets up networking for containers, assigning IP addresses, managing port mappings, and creating network interfaces and bridges. 2. Network isolation. It ensures that containers are isolated from each other on the network, allowing them to communicate while preventing unwanted interactions. Storage and volumes. 1. Volume management. Docker supports persistent data storage through volumes. 1. The daemon manages volumes, which can be attached to containers to store data externally from the container file system. 2. Storage drivers. Docker supports different storage drivers to manage container file systems. 2. The daemon handles storage driver operations, ensuring efficient and reliable data storage for containers. Logging and monitoring. 1. Logging. The Docker daemon captures and routes container logs, making it easier to monitor and troubleshoot containerized applications. 2. Health checks. The daemon can perform health checks on containers, ensuring that applications are running correctly and responding to requests. Security and isolation. 1. Security profiles. Docker uses Linux namespaces and C groups to isolate containers from each other and from the host system. 1. The daemon sets up these isolation mechanisms to provide process-level isolation and resource limits. 2. Capabilities. The daemon manages Linux capabilities, which control the permissions of processes inside containers. API server. 1. The Docker daemon exposes a REST API that the Docker client interacts with. 1. The API allows users to send commands to the daemon and manage containers and images programmatically. Plugin system. 1. The Docker daemon supports a plugin system that allows third-party extensions to provide additional functionality, such as storage drivers, network drivers, and logging mechanisms. Docker images, containers, and their relationship. Docker images and containers are key concepts in Docker's containerization technology. They are closely related but serve distinct purposes in the process of packaging and running applications. Let's explore their relationship. Docker images. 1. A Docker image is a lightweight, standalone, and executable software package that contains everything needed to run an application, including the application code, runtime, libraries, dependencies, and settings. 2. Images are built from a set of instructions defined in a Docker file, which specifies how the image should be constructed. 3. Images are read-only and are used as templates for creating containers. 4. Images are versioned, and multiple images can share common layers to optimize storage usage. Docker containers. 1. A Docker container is an instance of a Docker image that can be run and managed on a host system. 2. Containers are isolated environments that encapsulate an application and its dependencies, ensuring that it runs consistently across different environments. 3. Containers are lightweight, start quickly, and consume fewer system resources compared to traditional virtual machines. 4. Containers are ephemeral by design, meaning they can be started, stopped, and deleted without affecting the underlying host or other containers. Relationship between images and containers. 1. Image as blueprint. An image serves as a blueprint or template for creating containers. 1. It includes all the necessary components and configurations required for the application to run. 2. Container as an instance. When you run a container from an image, you are creating an instance of that image. 2. The container inherits the image's file system, environment, settings, and code. 3. Read-write layer. Containers add a thin, writable layer on top of the image's read-only layers. 3. This layer allows the container to store temporary data and modifications during its runtime. 3. Any changes made to the container's file system during its execution are isolated to this writable layer. To illustrate the relationship, consider the analogy of a class, image, and an object, container, in object-oriented programming. A class defines the structure and behavior of an object, and multiple objects can be created from the same class. Similarly, an image defines the contents and configuration of a container, and multiple containers can be instantiated from the same image. In summary, Docker images are the building blocks and blueprints of containers, while Docker containers are the actual instances that run applications based on those images. The separation between images and containers allows for efficient resource utilization, portability, and consistent application deployment. Thanks for watching.